Hello there students, thanks for joining me on this session, this tutorial for Open Loop Control Level 1. So, we've already studied the ideas of information processing, how that interacts with memory, how we can time that process, and we can look into the concept of reaction time. But what is it that's actually controlling the movement of a skill once it's underway? How does that occur? How is it that we can get a stored memory of a movement? We can set it to go, set it to activate and affect a muscular response, and then in some circumstances we can control it and adapt it. And when we talk about that, we are talking about the control of movement. So you see already, we do this via motor programs, or one theory at least is we do this via motor programs. And of course we know already that motor programs are stored in our long-term memory. They are stored movements in our long-term memory. And when we talk about open loop control level 1, we are talking about a form of control which has no feedback loop. It has no feedback loop. So let's actually put some characteristics of this in before we really determine how this is going to be represented pictorially. So we're talking about a form of movement control where no feedback is present. So let me give you an example of that. Let's take this golfer here. As soon as this golfer has prepared their club into the backswing position, the club comes down so fast, so rapidly, that between the time of preparing the backswing and then striking the ball, there is no feedback back to the golfer. And this is the case because the movement is what we would describe as ballistic. It's a ballistic movement. It's so fast that it doesn't allow either time or the sensation possible to control and adapt the movement because it's ballistic. So because of that, we also describe this open loop control. Because it's ballistic, because there's no feedback, we also consider it to be a form of subconscious control. A form of subconscious control. So in other words, once the movement is underway, there is no way of controlling and adapting the movement based on the feedback that one might have. So let's see if we can now apply that to the javelin player and then sort of illustrate it pictorially. We'd say the same thing. Once this arm begins to travel forward and propel the javelin forward, the movement of that shoulder, of that elbow, is going to be so fast, it's going to be so ballistic that this throw, in this case Goldie Sayers, as she throws here for Team GB, is going to be so fast that there's going to be no feedback loop back from the muscles back to the brain. Okay, that feedback loop cannot happen because the movement is so rapid. It takes place so quickly, so subconsciously, that there is no feedback. So in essence, if we now have a look at this model here, Goldie Sayers has recalled a motor program from her long-term memory. That's where she stores the memory of how to throw the javelin effectively. And then she's used those instructions to cause the movement of a javelin throw to occur. And we know she's done that using what we would describe as effector mechanisms. Effector mechanisms, and I hope you might recall from our information processing lessons, our information processing days, that effector mechanisms are things such as nerves and nerve impulses, and they are also muscular contractions. So as a result of that, as a result of those nerve, I made a right mess of it, I'm going to write that again. As a result of those muscular contractions, as a result of those nerve impulses, Goldie Sayers is able to translate a memory of a movement stored as an EMP, an executive motor program stored in the long-term memory, use those effector mechanisms and produce the movement of a javelin throw. And exactly the same would happen with the golf throw. Okay. Now, the interesting thing is that while the movement is occurring, there is no feedback back to the memory taking place. That is not possible, which is why we get this idea of an open loop. There is not the second half, if you like, the second semicircle of the loop backwards. It is open, and that's why we get this open loop level 1 control. So what are some other characteristics of this open loop level 1 control that we need to be aware of? Well, we would say that once you are in motion, it is not possible to do any kind of adjustment. So there is no adjustment. Once you are moving, the movement occurs, and then any feedback happens terminally after the movement has occurred. We can also therefore say it's a single decision. It's a single decision. So we have the decision to go, to perform, to throw, to strike. Sorry, let me I didn't mean to write channel layer. It's a single decision. You'll see why I wrote channel layer in a moment's time. So it's a single decision. So as soon as you decide to go, to strike, to bring down the club in the forward swing, to propel the arm over in the javelin throw, it's a single decision which controls the movement. And this is the last point I want to make on this, and it's a really lovely term and one I'd be really keen for you to learn for yourselves. It's operating on what we'd call a response chaining hypothesis. Okay, a response chaining hypothesis, and that is to say that as soon as the decision to move, to throw, to strike is taken, that the actions themselves, so the movement of the shoulders in the golf swing, actually act as a chain, a stimulation for the hip movement to happen through the ball, for the follow through to take place after the ball has been struck. There's a chain of responses that actually happen because the initial decision, the only decision to strike downwards, has been taken. It then puts into effect a chain of actions and reactions which produce the whole movement technique. This is what we describe as open loop control of motor programs or executive motor programs with no feedback, for ballistic actions, for subconscious control, and it's that single decision with no adjustment, the response chaining hypothesis. Thanks for listening.